Welcome to The Explainer. So, today we're diving into a massive paradigm shift. You know that skill you've probably spent the last, 2 years perfecting? Traditional prompt engineering? Well, for developers and AI practitioners, it's actually becoming obsolete, right? We've all been there, spending hours agonizing over the exact phrasing of act like an expert, or twisting ourselves into knots trying to format the perfect JSON output. But guys, the game is changing entirely. Let's get into it. Okay, picture this. You hear about frontier models like Claude Opus 4.6 boasting these massive 1 million token context windows. What's your very first instinct? If you're like most developers I know, the immediate temptation is just to dump your entire code base, all your documentation, maybe your system logs, right into the prompt. It feels like a magic bullet. Just hit Command A, copy, paste, and let the AI sort the whole shebang out. You think, hey, a massive context window solves everything. Well, actually, scratch that. It turns out that approach is a massive trap. And that brings us to this fundamental shift in how we build AI applications. We are moving completely away from the old paradigm of prompt engineering, endlessly tweaking and formatting our instructions to coax out the right answer. Instead, the new absolute necessity is context engineering. It's no longer about writing a novel of instructions. It's about being a curator. You have to find the absolute minimum set of high-signal tokens to feed the model. So you're shifting from being a micromanager of instructions to essentially a high-level filter of information. So about that 1 million number, the reality of a 1 million token limit is incredibly deceiving. While the ceiling is frankly huge, a recent Databricks study proved something wild. Model correctness actually plummets way, way before you hit that limit. In fact, right around the 32,000 token mark, performance just falls off a cliff. Just because a model can technically accept 1 million tokens absolutely does not mean it can effectively reason over them. Cramming more text in literally starts destroying the quality of your output. So here is the crucial takeaway. This bloated data-dumped approach, it inevitably leads to what we call context rot. And this is perfectly characterized by the lost-in-the-middle phenomenon. It is exactly what it sounds like. Think about reading a 500-page legal document. You remember the intro, you remember the conclusion, but that one critical clause buried on page 250, you completely forget it. The model forgets it just like a human would. Large language models heavily weight the very beginning and the very end of a massive prompt, but they effectively ignore vital data buried halfway through. And to make matters worse, massive context doesn't just fail quietly. It fails in 4 very specific, measurable ways. First up is poisoning. This is where the model starts hallucinating because outdated facts like, say, deprecated API endpoints were left in the context. Second is distraction. The model overfocuses on massive historical logs instead of applying its actual training knowledge. Third, confusion. Giving the model too many irrelevant tools or docs actually degrades its responses. And finally, clash. This is when different parts of your bloated context directly contradict each other, which basically leaves the model completely paralyzed. Let's look at a practical example. Say, a query about the 2019-2020 Champions League final. If the location of the match is stored in one document, but the winning team is stored in a completely different chunk, your critical facts are fragmented. Blindly increasing your context window size doesn't magically teach the model to connect those disjointed dots. It just means you're feeding it more hay in hopes it finds the needle. The reasoning breaks down because the model simply cannot bridge the gap between fragmented pieces of info spread across thousands of lines. So, if the old way leads to high latency, runaway API costs, and hallucinating models, how do we fix it? That brings us to part 1, the solution, context engineering. Okay, your operational playbook for context engineering really boils down to 3 essential steps. Step 1, meticulously curate the absolute minimum set of high-signal tokens. Don't send a whole file if you only need a single function signature, right? Step 2, leverage the rule of extremes. Because of that lost-in-the-middle issue we just talked about, you've got to place your absolute most critical information at the very beginning or the very end of your prompts. And step 3, cleanly separate your static context, like your coding standards, from your dynamic, real-time data. By caching the static rules, you only pay compute for the new data. This separation is exactly what lets you utilize prompt caching effectively and dramatically slash your costs. A core tool for pulling this off is just-in-time retrieval. You'll often see this handled through a RAG pipeline, retrieval augmented generation. Instead of preloading everything up front, your system acts like a hyper-efficient librarian. It dynamically searches a vector store and fetches only the exact relevant context, the precise chunks your model needs exactly when it needs it. This keeps your context window incredibly lean, highly effective, and 100% focused on the task at hand. Let's put some numbers to this to see the real-world efficiency. Check out this stark difference in average token cost per operation. By engineering your context tightly through direct command line interfaces, or CLIs, you're averaging about 200 tokens per command. Contrast that with using bloated protocols like the Model Context Protocol, MCP, which can gobble up upwards of 32,000 tokens for the exact same operation just by constantly loading unnecessary schemas and history. Treating your context as a scarce resource is an absolute game changer for optimizing your production pipeline. And here's the coolest part. This extreme curation unlocks something incredible: the true power of small language models, or SLMs. When you feed highly curated, high-signal context to an SLM, like IBM's Granite models, for example, they can perform specialized enterprise tasks using 10 times less compute than those massive frontier models. 10 times! That means incredibly fast response times, but even better, because they're so lightweight, you can run them locally for maximum data privacy. Your proprietary code never has to leave your servers. But of course, they only shine if you engineer the right context first. Which leads us to an exciting question, and part 2, the next horizon, breaking future context limits. Because what happens when you genuinely need to process inputs that are 2 orders of magnitude beyond current context windows without triggering context rot? The absolute frontier here is recursive language models, or RLMs. This is a massive departure from the old way. Traditional models try to read everything at once, basically drinking from a fire hose, and inevitably they get lost in the middle. RLMs, on the other hand, programmatically decompose long prompts into much smaller, manageable snippets. Instead of a single massive inference step, they recursively examine, search, and synthesize info, calling themselves over and over. It's literally like watching a senior engineer work through a massive, unfamiliar codebase, right? They check one file, learn from it, and then decide exactly what to open next. Because they actively navigate to relevant information rather than just passively receiving a massive data dump, RLMs solve the lost-in-the-middle problem entirely. This is huge. It enables AI agents to systematically analyze thousands of files at once, perform long document reasoning well beyond traditional limits, and handle complex, multi-stage problem decomposition. They don't just sit there and read the context. They actively investigate it. They pull the threads they need and completely ignore the noise. It is a total shift in how we reason about enormous datasets. So now that you understand exactly why endlessly crafting the perfect prompt is dead and why curating the perfect context is the true future of AI development, here is the real question to leave you with. What incredible, context-aware applications will you build when these limits truly disappear? Thank you for joining me for this explainer, and I really hope this paradigm shift helps you build faster, smarter, and incredibly efficient AI systems.